Thompson Construction Group's training on confined spaces. Thompson policy ensures that a confined space entry permit is completed prior to entering any area that could be considered a permit-required confined space. Serious or fatal accidents caused by lack of oxygen or the presence of toxic or explosive vapors can be prevented with foresight and the use of proper safety procedures. Here are some questions to ask when thinking about confined spaces. How would you know one if you saw it? Is it more than just a hole or small space? What kind of smells might come from it? Is it big enough for more than one person? How do you know when you need a permit? What are the different hazards? How do you rescue someone? And what is your role to enter a confined space? In these images, we see some examples of confined spaces. According to Thompson policy, all personnel must review and understand the information listed on the confined space entry permit prior to entry. All entrants are required to wear a safety harness with a lifeline attached. In the event that there is even a possibility of entanglement with machinery or other personnel within the confined space, the safety harness will be worn without the lifeline upon approval by the TCG management or safety personnel. The lifeline will be placed outside the confined space entry point and maintained readily available for rescue purposes. A safety harness for non-permit required confined spaces should be worn as required by job conditions. One of the characteristics of a confined space is that it has limited and/or restricted means of entry and/or exit. This is also sometimes referred to as limited egress. One quick glance at these two workspaces reveals spaces that have restricted means of entry and exit. Entering these spaces is quite a bit different from walking into the front door of an office building. In addition to having a limited means of egress, another characteristic of a confined space is that it is not designed for continuous occupancy. Does either of the spaces in these images look as though it was designed for continuous human occupancy? Remember, there are a number of contaminants and hazardous substances that would make staying in a space for any extended period of time very harmful. Here are some hazards to be on the lookout for in confined spaces. One of the hazards to look out for is an oxygen-deficient atmosphere. This is an atmosphere that contains less than 19.5% of oxygen. Some processes can consume oxygen in a confined space, like combustion of flammable materials such as welding, cutting, or brazing. More subtle consumption occurs during bacterial action like fermentation or decomposition. Oxygen can also be consumed in the formation of rust on exposed surfaces. The number of people working in a confined space and the amount of physical activity changes oxygen consumption. Finally, levels can also be reduced by displacement of other gases. Another hazard to recognize in a confined space is a flammable atmosphere. Flammable atmospheres are generally the result of flammable gases, vapors, dust concentrations in the air, or an oxygen-enriched atmosphere. An oxygen-enriched atmosphere will cause flammable materials such as clothing and hair to burn violently when ignited. Work conducted in a confined space, such as spray painting, coating, or the use of flammable solvents for cleaning, can result in an explosive atmosphere. So could welding or cutting with oxyacetylene. Combustible gases or vapors can accumulate within a confined space when there is inadequate ventilation. A toxic atmosphere is also very hazardous in a confined space. A toxic atmosphere is generally the result of one or more of the following: products stored in the space, work being conducted in the space, or areas adjacent to the space. Products stored in a confined space can be absorbed by the walls and give off toxic vapors when removed or when cleaning the residual material. Examples of work include welding or brazing with metals capable of producing toxic vapors, painting, scraping, and sanding. Many of the solvents used for cleaning and/or degreasing produce highly toxic vapors. Toxic fumes produced by other processes near the space may also settle into the confined space. Mechanical and physical hazards are often overlooked in a confined space. Problems such as rotating or moving mechanical parts or energy sources can create hazards. All rotating or moving equipment such as pumps, process lines, electrical sources, etc. must be identified. Physical factors such as heat, cold, noise, vibration, and fatigue can contribute to accidents. These factors must be evaluated. Excavations could present the possibility of engulfment. Employees shall be protected from cave-ins by sloping, benching, or shoring systems when the depth of the excavation is more than 4 feet. Air monitoring may also be required. Determining whether or not the atmosphere in a confined space is hazardous is done by testing the air inside the space, sometimes called air quality testing, air monitoring, or air sampling. This can be done by a trained employee with a variety of testing tools. The air within the confined space should be tested from outside of the confined space before entry into the confined space. Care should be taken to ensure that the air is tested throughout the confined space, side to side and top to bottom. The air within a confined space should be tested from top to bottom, left to right, and front to back. Always test the air at different levels to be sure the entire space is safe. Good air near the opening does not mean there is good air at the bottom or back of the space. Thoroughly testing the atmosphere in a confined space is important because every gas has different physical properties that causes it to naturally inhabit a space in different ways. Methane, for example, is lighter than air, so it naturally moves to the top of a space. Carbon monoxide flows with air. Hydrogen sulfide is heavier than air, so it generally settles at the bottom of a space. Confined spaces can also be dangerous because of the possibility of containing an immediately dangerous to life or health substance or situation. Immediately dangerous to life or health, or IDLH, means any condition which poses an immediate or delayed threat to life, or that would cause irreversible adverse health effects, or that would interfere with an individual's ability to escape unaided from a confined space. Some materials, like hydrogen fluoride gas or cadmium vapor, may produce some immediate severe effects on a person that may pass without the need for any medical care. However, just 12 to 72 hours later, the person could suffer a fatal collapse. Each and every person that enters a confined space has a specific set of responsibilities. A supervisor knows the hazards of the space, including the mode, signs, symptoms, and consequences of exposure to the hazards. He also verifies everything: the permit entries, the specific testing, the procedures and equipment to be used, the rescue or emergency plan, and everything before anyone goes into the space. The supervisor is also responsible for removing people who do not need to be around or in the space, and he also determines who will be the supervisor in case he or she must enter. Finally, the supervisor is responsible for terminating the entry and canceling the permit when everything or everyone is completed and accounted for by way of the permit and policy. The attendant responsibilities are as follows. The attendant monitors entrance during the job and during entry and exit to help ensure their safety. The attendant may not abandon their post for any reason unless relieved by another qualified attendant. The attendant monitors atmospheric conditions in the space prior to and during entry and controls access to the confined space. The attendant summons emergency assistance as needed but does not enter. He knows the hazards in and around the space and takes action on the same. He communicates with entrance. Finally, the attendant keeps records of confined space work, such as air test results, personnel entry, and exit. He never enters the confined space. The entrant has a set of responsibilities also. He knows the confined space hazards plus the signs, symptoms, or consequences of exposure to those hazards. The entrant properly uses the equipment required for the job. He communicates with the attendant as needed for monitoring or for evacuation of the space. Finally, the entrant alerts the attendant when something is not right and immediately exits the confined space at the sight, sound, smell, taste, or feeling of any trouble. In the unfortunate case of having to rescue a team member from a confined space, you generally have 3 options. First, the entrant is able to exit space under their own strength. Second, a retrieval system or method can be used to remove entrant from the space. A mechanical device must be available to retrieve personnel from vertical-type permit spaces more than 5 feet deep. Thirdly, a qualified confined space rescue team is notified and removes the entrance, or a combination of all 3 of these methods. The first 2 of these images are of actual rescues. In the third image, you can see a tripod, which is a mechanism commonly used to vertically hoist workers from a confined space situation. Remember, acceptable entry conditions must exist before entering a confined space to begin work. Acceptable entry conditions means that conditions must exist in a confined space to allow entry and to ensure that employees involved in a confined space entry can safely enter into and work within the space. Confined spaces are naturally environments that can be very dangerous to work in. Thomson's success in working in confined spaces is a product of experience, following the proper policies and procedures, and treating confined spaces with the respect they command. Finally, employee training is mandatory. In most cases, you will need to complete additional training before being permitted to work in a confined space.